Hi, so this is the second video talking about the cranial nerves, in which I'll look at cranial nerves 5, 7, 8, 9, 10, 11, and 12. So to start with, we have cranial nerve 5, and this is our trigeminal nerve. Our trigeminal nerve has the function of sensation to our face, and it has motor to our muscles of mastication, which is chewing. Now, our cranial nerve can be broken into 3 different branches, and this is our ophthalmic nerve, our maxillary nerve, and our mandibular nerve, sometimes in that order called cranial nerve 5A, 5B, and 5C. So, as we said, they provide sensation to our face. So, our cranial nerve 5A does the superior part, then we have our cranial nerve 5B, and our cranial nerve 5C doing the lower part around the chin. The cranial nerve 5 also provides sensation to the inside of the skull and to the meninges. And this is important because this means that you can get referred pain to the face from problems that are going on inside the head. We also have our muscles of mastication, to which they provide motor, and these are our temporalis, which sits around our temporal region, our masseter, our medial pterygoid, and our lateral pterygoid. Our lateral pterygoid is the only one which is involved in opening the mouth, and as there's only one muscle involved in opening the mouth, this is a much weaker movement than closing the mouth, which is done by the other 3. So next we move on to our cranial nerve 7, which is our facial nerve. And this gives us motor to our facial muscles, as well as giving us our taste sensation, or to the anterior part of the tongue, and it causes some saliva production depending on the glands. So this has a number of brainstem nuclei, including the facial nerve nucleus, our superior salivatory nucleus, as it provides our lacrimal gland and our parotid gland, and our nucleus solitarius. So the facial nerve has a number of branches, and the mnemonic for remembering this is the zombie bit my chin, where some of those words can be replaced. So we have our temporal nerve supplying the most superior part, then our zygomatic, buccal around the mouth, our mandibular below the mouth, and our cervical, which goes down into our neck. And you can test these by getting someone to raise their eyebrows up, getting them to do a big grin, or getting them to purse their lips. And these will all test different branches of the facial nerve, and therefore you can check that each part of the facial nerve is working effectively. So once it's passed out of the internal acoustic meatus, the facial nerve has a slightly long route through the bone till it then arrives on the face around the parotid gland. And this is called the facial canal. So it enters at the internal acoustic meatus, and then it gives off branches, including the nerve to stapedius, which is a muscle in the middle ear that connects to stapes, the chorda tympani, which then runs through to our mouth and supplies sensation to our tongue, or taste to our tongue, and our greater petrosal nerve, which runs up to our lacrimal glands and allows us to produce tears. It then exits at the stylomastoid foramen, and this sits just behind our ear and then runs around to our parotid gland, and it then runs through our parotid gland. So there are a number of places that our cranial nerve 7 can be damaged. So our sensation of taste, as we said, the anterior 2/3 of our tongue is supplied, the taste is supplied by cranial nerve 7, and our chorda tympani, and then the cranial nerve 5C supplies our normal sensation, so that sort of touch and pain and temperature in this area. And then the posterior part is supplied by our cranial nerve 9, which does both our taste and our normal sensation. So our taste goes from the papillae on the tongue into our cranial nerve 7 or 9, which goes back to our nucleus solitarius, which then travels to the thalamus, because everything does, and then back to our cortex. So the branches of our chorda tympani run for a while with our branches of our cranial nerve 5C, and this means that if one is damaged, then the other is likely to be damaged in the same place. So our cranial nerve 8 has the functions of hearing and of balance, hence the name vestibulocochlear nerve. So our hearing pathway begins with our cochlear nerve and then runs back to our vestibulocochlear nucleus. This can then decussate to the other side at our superior olivary nuclei, which sit around the olives of the brainstem. And these then ascend and run to the inferior colliculus, which is another relay point, and these then run to the medial geniculate nucleus of the thalamus. This is where they will then synapse again. So as we said earlier, we have our optic nerve synapses at our lateral geniculate nucleus, and our hearing pathway is at the medial geniculate nucleus. And this then travels to our primary auditory cortex, which sits in our temporal lobe. So how does our hearing system work? Well, this is a brief look at the anatomy of the auditory system. And within the auditory system, we have these scala vestibuli, scala media, and scala tympani, which are essentially the three different areas. And these are separated by membranes. And the most important parts to remember are our basilar membrane and our tectorial membrane. As sitting between here, we have our organ of Corti, which has hair cells. And these hair cells become depolarized by sounds, and that's what causes the depolarization within our cochlear nerve, which then travels back and begins and that's how the auditory system works. So the way sound travels to the organ of Corti is it travels through our outer ear to our tympanic membrane, and then it travels through our malleus, incus, and stapes. The stapes connects to the oval window and causes distortion of our vestibular membrane as it passes through. And then this distortion of our vestibular membrane, as we said, sits close to our tectorial membrane and basilar membrane. And that will depolarize the hair cells in our organ of Corti, which will cause the activation of an action potential in our cochlear nerve. So we also have our vestibular system as part of cranial nerve 8, and this is to do with balance. So we have a static and a dynamic part of our vestibular system. The dynamic part has our three semicircular canals, and these control our head movements. And then we have our static system, and our static system has one that controls our horizontal orientation and one that contains our vertical orientation. So our utricle or utricular macula contains our horizontal orientation, and this allows us when we're walking forwards to keep our center of gravity in front of our feet, so we don't fall over backwards. Our saccular macula does our vertical orientation, and the way that I remember this is because if you drop a sack, it will fall, so that's vertical. And if you start to fall down, this will generate an extensor thrust, so it allows you to extend out and try and stop yourself from hitting the floor face first. So now we move on to our cranial nerve 9, which is our glossopharyngeal nerve. And this has a number of functions, including taste to the back of our tongue, sensation to our pharynx, motor to our pharyngeal muscles, and it has some parasympathetic functions as well. So it's got a number of brainstem nuclei, so it has the nucleus ambiguus as its motor part, the nucleus solitarius as its sensory part, and then it also has a role in the inferior salivatory nucleus, producing saliva from our submandibular and sublingual glands. Next, our cranial nerve 10, or vagus nerve, and this has a function in just about everything, including a small area right on the back of the tongue which does taste. It has sensation in our larynx, motor to our larynx and pharynx, and it has parasympathetic functions as well. And this also has a part in the nucleus ambiguus as its motor part, and sensory in the solitarius. And the dorsal motor nucleus of the vagus has its parasympathetic supply. Cranial nerve 11 is a spinal accessory nerve, and this provides function to our trapezius and sternocleidomastoid. So the trapezius allows us to lift up our shoulders, and our sternocleidomastoid allows us to turn our head. So these are the movements that are tested if you're testing this nerve. And our cranial nerve 12, or our hypoglossal nerve, allows us to move our tongue. So if you get somebody to poke out their tongue, then it allows you to work out if this cranial nerve is working. And if it's damaged on one particular side, then the tongue will move towards the side that is damaged. So if you have damage to the cranial nerve 12 on its right hand side, then this will damage the right hand side of the tongue, and this means that the left hand side of the tongue will push out further, so the tongue overall will seem like it's moving towards the right hand side. So this is why some people say the tongue never lies is a good way of remembering this. So that's a quick summary of the rest of our cranial nerves. I hope that's been helpful. Thank you.